What the hell? Ugh. Good Lord, this is insane. Now, I definitely was not expecting that. idcwoodcraft.com. I'm Garrett Fromme, CEO of IDC Woodcraft, a CNC router bit supply company for you and your CNC router. And in this video, we are going to talk about vacuum tables on CNC routers like I have on my Phantom CNC router here. Specifically, we're going to be talking about the #1 problem when it comes to vacuum tables, and we're going to walk through a possible solution. We're going to see if this works together. So first of all, we're going to talk about what a vacuum table is, what it's for, then we'll get into the problem, and then we'll dive into the solution. So when it comes to vacuum tables, it's just essentially another tool for work holding. By work holding, to hold your project in place. There's either clamps that we use, or we'll use the CA glue method, or if we want to get more efficient and make things really easy, we have a vacuum table, like the Phantom has here. You slap your project on the table, you position it, turn on your vacuum, it's held down, you go into your carve without fiddling with clamps, without fiddling with the CA glue. It's very quick, easy, and efficient. Then comes the problem. And that problem that most CNC router owners run into when it comes to vacuum systems is the hold down power. The worst thing that we can experience when we are going through a project in our CNC router journey is that project moves while we're doing the carve. And that is extremely frustrating, ruins a project, and sets us way back. So when it comes to vacuum tables, we want to make sure we have enough suction on the table, or hold down power, downdraft, whatever. We just need the thing to have enough ass to hold the project in place so it won't move throughout that entire carve. I've got the problem right now. I need to have this piece of maple beam held down rock solid on my Phantom CNC router because IDC Woodcraft is introducing a brand new CNC router bit that is built to really chew through wood. It's called the Beast. It's this right here. It is a roughing bit that is designed to be extremely rugged, and I'm testing the final tests on it. I want to get it up to 800 inches per minute at 1/2 inch, maybe even 3/4 of an inch deep through this maple beam. That's a lot of force that is being applied against that beam by that router bit as it's being pushed through the material. And that's enough force to move this we'll say 30-pound piece of maple. Hardwood, right? So here's where the problem comes in that those of you who own a CNC router with a vacuum table run into. It's something called leakage. This beam right here is maple, and this is what I want to cut. And it does not cover all the zone, the vacuum zone. If it covered the entire zone of the vacuum, a zone being the area that the vacuum is like being applied to. As you see, I have 4 valves on the Phantom here, and each valve covers 1 corner of the machine, or a 24-inch by 24-inch vacuum zone. Well, this clearly it's 10 inches wide. So I have 14 inches of exposed zone. Air passes through that, the MDF, and just won't hold down strong enough. And so I need to fix this problem. Well, just so happens that a company contacted me called All Star CNC. And they said they've got a solution to this problem. Kind of correlated with where I was going anyway. I mean, the timing was right. Talk about synchronicity. So they said, okay, we got a problem, we got a solution. And they showed me some videos, and I said, okay, I got to check this out. So they sent me this sample here. And what this is a padding that goes on top of your spoil board. Seems simple enough. It's got some holes in it, but you can see it reduces the volume or the leakage area that you may get on your vacuum table. So what we're going to do is we are going to actually work this, and we are together going to see if this works, and if it does, we might have a solution here. Okay, so what I have to do is I have to dismantle my spoil board. You're going to watch. I'll talk to you a little bit as I'm doing that. So I have to put a new seal, and then I got to put the spoil board back on and then resurface it, and then we are going to apply the padding on top and see what this thing does. Now I want to show you the problem that I've run into. So the issue I run into is I have this big piece of maple here that I'm going to test. I put it on the table. I've got 2/3 of this vacuum zone exposed. When I turn on the vacuums, so now this zone is now active, this zone and this zone, and there is some hold down. There's not a lot of force here. Now I'm going to let it sit there for a minute, let the vacuum build up, and then try to push it around. And it takes too much force. It's not enough force hold down power. There's not enough hold down power for me to run this bit through this material at 800 inches per minute. Let alone, we'll shut off this back vacuum, let alone little pieces like this. We'll put the piece on here, and clearly the vacuum is working because it stops so quickly. But I've got all this area where all this leakage is at, and I want to see how well it's going to work with a piece this small. But of course, it's necessary for me to get this piece going because I need to test this bit right here. So what you and I are going to do is try this out. I'm going to dismantle the spoil board and put that seal in, put the spoil board back on, the Phantom, and then we are going to resurface it, put the padding on from All Star, and then I'm going to see how it works with this little piece, and we're going to see how it works with this big piece of maple here as I run the beast through it as hard as I possibly can. So let's get rolling. Before I remove the spoil board, I want to make sure that it goes back on the right way. So I'm going to mark this top left, and I'm going to mark the corners of the board in its position. That way, when I go to screw the board back in, the screws will drop right into the holes that they're already in. So now both sides of the board are marked appropriately. I got the corner, I got a little line there, top left. On the Phantom 4x4, which is what I have here, the spoil board is screwed directly into the vacuum table. And you'll see how I've got it. Now I've had a couple mistakes as I was figuring out where to do that at, where to screw down at, because there's voids down in there, as you'll see in just a minute. So we're going to back this thing off, pull the board off, and then we'll take a look inside. This is what the vacuum table looks like underneath. Here's zone 1, zone 2, zone 3, and zone 4. And so the vacuum draws down through these two ports for zone 1, and of course the air sucks through all these channels. So one of the reasons I was struggling too is because I have no seal here, and I could tell there was a leak in zone 2. Before I put the seal down, I'm going to clean out all this because dust does get through that spoil board, and so there's a little bit of dust through here. So we're going to get all that cleaned out, and then we'll put the seal on. Now it's time to put the seal in. So the seal is going to go around the outer perimeter only on all 4 zones. So this is the All Star seal, and it looks like it comes in one long strip. So rather than try to cut as I go, I'm going to fit a seal in on the strip, and I'll cut it when I'm done getting it fitted. Now the first thing I notice with this seal that is different from other seals is it's rectangular, right? So it's going to drop right into the groove and fill out the groove. This is as opposed to the round seal or the smaller seal. Now, just by setting it in there, it is slightly raised up, but it will crush down when the board gets pulled down. So we're going to run this on around. Okay, it's not normal for me to put little musical inserts in the videos, so I just figured out what the hell, I'll give it a shot. If it's cool with you, then give me a thumbs up or put a comment down below and say, scratch the music, Garrett, we don't want it. I've got a tiny gap there. I want this to overlap a little bit and compress just a tad into it, but I want to get all the stretch out of it first. So I'm going to run my finger just lightly backwards around the whole perimeter, just to get any stretch out. I'm very lightly pressing it, just kind of getting everything seated. Then when I cut the end piece here, I'm going to let it overlap a little bit, about 1/2 inch. And then I'll push that down in, and now I'm going to have a little bit of a hump. And so now I can start to work that out just by running it backwards a little bit. And if I can't, then I can always trim off some of the excess on it. And it looks like that's what I'm going to need to do. So we're going to, it's about 1/4 inch overlapped. I'm just going to trim off 1/8 inch, push it in there, and I'll compress it down in and stretch it the rest of the way, and make sure we get rid of the rest of our debris. We don't want it to be sucked down into our vacuum port right here. You know, I just had a memory. Cutting these little 2 pieces off with this pair of scissors. This scissors goes back 33 years. Back when I was on the squad, I was a firefighter EMT for a volunteer department for about 7 years. And as an EMT, we always carried this pair of scissors on a belt. These are the things where you cut off clothes when you need to, or cut a seat belt. This pair of scissors, as cheesy as it looks, can cut a penny in half. Went on a lot of ambulance runs. I was pretty fortunate though. For ambulance, I didn't see a lot of catastrophe. There's a little boy though named Henry. We got called because he hurt his finger. Those kind of calls were a pain in the ass, but I liked Henry, and I always went back to visit him after that, see how he was doing, say hi, became friends of the family. The hardest time though is when I was running a fire run once, and I was the engineer on the truck. That meant I was driving the truck and manning the pumps at the truck from the hydrant, and from the pumps to the truck to the fire hoses. We had a house fire, and when the call came out, there was a child entrapped in a house fire. You best believe we are on it. And within 3 minutes, everybody was at the firehouse. It's a volunteer fire department, so people didn't stay there at the time. But we got down there, that whole house was ablaze when we got there. We knew that if there was someone inside, they didn't make it. And that's what happened. There's a little girl, her name was Katie Wells. She's 4 years old, died in that house fire. That was a tough time for all of us. Part of running a service, have you ever been in the services of any of them, like law enforcement or military, fire, EMS, and then you've probably run into some kind of incident that you just remember. It never goes away. Katie Wells was the one that never went away. Anyway, a pair of scissors reminded me of those days. Let's get back to this. So everything's pretty well sealed. Just a minor, tiny gap right here on this one. I'm going to work this one out as best as I can. Maybe I will have to stretch just a little bit to get it. Now I'm going to do just one more vacuum cleanup on this, and then we're going to clean up the back side of the spoil board. This is where the screw came out, so I got to get that flat, and then I've got a couple other spots here. Just got to make sure it's all flat, and we'll reposition it on the table and screw it back down. What? Oh God. Here I go again with that friggin' music. Now, one of the things I found as I'm putting the spoil board back on is the compressive nature of the seal. Since it's sticking up a little bit high, it's drawing down where I had the screws at, but after a while it starts to lift up. So I've got a little bit of a gap here. So I have to add more screws to hold this down. Now I've got enough screws in the middle because I have them here and in the middle and there, but I don't have them like at the 12-inch interval, so I have to add more screws on the 12-inch interval on the outer perimeter. Before we go on, if you are using a vacuum table, one of the things that you absolutely want to do before you put your MDF up on the table to start it is you want to seal the edges of your MDF. Here's why. MDF is porous, and if you've ever messed with it, it's pretty smooth on one side and on the other. So air is going to flow through there, but if you ever cut MDF open, you can kind of see it here. You just make a cut. It's nice and compressed right here, but it thins out in the middle. And it's compressed over here too. So air that's being sucked from your vacuum, this is generally going to be the path of least resistance along the edge of the MDF rather than this smooth area that's been compressed even tighter than in the middle. So this all needs to be sealed all the way around your spoil board. So all you do is just take some wood glue, put it on there, and I'll just run it in with my finger. And I'm rubbing it in as well. So it kind of pushes down into it. And we got a little bit of coming over the edge there. I'll clean that off. And after it dries off, I just take a scraper and just make sure I break off the edges. But once that's set, now it's sealed. But you want to do that all the way around the spoil board. Of course, make sure you let it dry first, but this is an absolutely necessary thing you have to do when you're using a vacuum table. You want all the suction to be coming down through the top, not in from the sides of the board. Now, I've got everything secured down. Before I move on, I want to check the seal or the hold down power with the seal relative to without. You remember, before, the board just wouldn't hold down. This big piece of maple beam wouldn't hold down very well. Now I've got seals all the way around in each zone. So we're going to see what the difference is just by adding a seal. But let's check out the little piece. Let's see what kind of difference it makes for something like this. So we're going to pull this one off the zones. And we're going to leave zone 1 turned on. It has a seal. And I'm going to drop this board on. Okay. Let it draw a seal for a minute. Nope. No dice. We're going to try this guy again. Turn the zone off. Drag it in. So right now I am only working with one zone, and I'm going to turn it on. So right now I can move it around. Zone 2 is not on. Now zone 1 is on, or zone 2 and 1 are on. And there it goes. So now I'm going to resurface the spoil board, and then we are going to put the pad down, and we're going to see what the difference is with this on one zone. and with this guy. So you see, I can't move it this way, but I can move it this way. Let's see if we can eliminate that with this All Star CNC mat that goes down. Well, at this point, I'm going to throw the music in again. I guess it's kind of like an addiction right now. Just got to do it. The spoil board is all held down now. The screws are all 12-inch spacing. There's no gaps between the spoil board and the vacuum bed. Everything's pulled down now, and we know that this seal works. If you don't have a seal on your vacuum bed, I made a mistake in not putting it in there, and now I see why. I had some issues before. Make sure you put a seal in your vacuum bed. But I already got to recommend the All Star seal, because that just made a huge, huge difference on this. It's the only seal I used, but damn, the stuff worked really good. All right, so now it's time to surface the spoil board. Since I took it off, whenever you take a spoil board off, you have to resurface it. I'm going to resurface it with the IDC Woodcraft Ultra Smooth Cutting 1.5-inch surfacing bit. It's an IDC Woodcraft bit. I could use the 2.5-inch bit that I have, but because IDC Woodcraft is a CNC router bit supplier, I like to run out the tools that I supply to you to always look for issues that it may have, you know, if it wears out too quick, things like that, because then I need to change some designs. So I'm always working with the IDC Woodcraft tools. As far as this bit, we're going to run it at 600 inches per minute. I'm going to run in 4 directions on the Phantom CNC router, and we're going to run back and forth in the X direction, then we're going to go back and forth in the Y direction, and then I'm going to do diagonal this way and diagonal that way. I like to get smooth all the way around and make sure it's just darn smooth. It's probably overkill, but that's the way I like to do it. So we're going to get this puppy put in, then we're going to put that mat down and see how that stuff works relative to not having a seal, to having a seal, to having the All Star CNC mat that is supposed to really change the game, especially on that little piece of wood. That'll be really interesting. Now we're going to have another song. I kind of like that whistling song I played before, so you know, it's got that kind of just strolling down the road, chilling out, whistling, looking at the birds and the trees. And well, we've got the spoil board ready to go to put the All Star vacuum mat down on the spoil board on the Phantom CNC router 4x4. So what I'm going to do is I am going to take the pad and I'm going to set it down on zone 1 and zone 2, and I'll leave zone 3 and zone 4 uncovered so I can do a dead comparison on this. So let's just put it on there and I'll walk you through how I'm setting this up. So each mat has adhesive on the back, and so we'll have to position each one carefully. And every step of the way, I'm going to make sure I'm very clean on the area where I'm placing the mat. Well, I now have zones 1 and 2 set down, and 3 and 4 are not. Now, this takes a little bit of time, and I was trying to be as careful as I could not to get seams like this. I want to take advantage of these holes. Now, what is the point of this pad and the science behind it? What this is doing is reducing the suction area by, I think, up to 85%. I mean, I'll put stats and statistics and information down below in the thing, but if I remember right, just by doing this, it's the leakage area is cut down by 85%. So that will be really interesting to see what's going to happen now. So this is All Star, and this is their pad. And now we're going to see how well it holds down this 5x10 piece of oak and this guy. We will do this side and we'll do this side. Just a side-by-side comparison. Let's see how this all works out. Okay, first we are going to do this board here. I love my long mill. That's my other benchtop CNC router. And so I have zone 4 turned on, which is this zone right here. So it's 1, 2, 3, 4. And all the other zones are turned off. So we're going to go turn on the vacuum. So I'm going to turn zone 4 off for a minute. Okay. Then we'll turn it on. Zone 4. Okay, it's on. I can bump it around. Alright, so we're going to turn zone 4 off. Zone 1 on. So now this one's turned on. If I pull up on it like that, it pulls away, but sideways pressure, okay, I get so what I can't do is actually machine it by itself right here, but it's definitely holding a lot better. Let's flip it over. Ooh. Ooh. That really has a significantly different holding power. Switch zones. Remarkable difference. Okay, so that was a pretty dramatic difference between here and here with this piece of 5x10. You could see that I was literally pulling on this board and then it would break away. So that one is pretty cool. Now it's time to try the piece of maple. What you're about to watch with this padding from All Star CNC for your vacuum table on your CNC router, like I have on my Phantom CNC here, with the pad relative to without the pad is going to blow you away. It completely did me. If you have a vacuum table on your CNC router, this is the part that you really have to watch and pay attention to and get blown away by. So let's get back with the video and the testing and watch what I can do with this pad relative to without the pad with this piece of maple. So we're going to throw that up on zone 3 and 4. Turn the vacuum on. Make sure 3 and 4 are turned on. 1 and 2 are turned off. Let it draw a vacuum for a minute. Nope. Is it working? That's weird. It feels like it's working. As I move back here, it gets a little tighter. There must be a leak in the board around here somewhere. But it's holding, but let's check this out. We got this is smooth backing board for photos. Oh yeah. Works there. Starting to rip it. You can't pull up on this at all. If you pull up, you lose your vacuum. Okay. So I'm not sure why this is not holding over here. Let's see what's going on over here with this thing. Okay, zone 1 and 2 are on. I'm going to show you 1 and 2 are on. Let's see. I pulled up on it and broke free. Let me get my sledgehammer, see if I can move it that way. Any kind of pulling up on it breaks the vacuum. It's actually a decent hit. I'm getting about 1/8 of an inch at a time. Let's try it over here. That's a lot of force going in, an impact force going into that. Alright, so I find this kind of interesting. I got this piece of maple that won't even hold on this side. I guess it's got too many pores. We know this side is working, but it's locked down over here. The true test is going to be driving the Phantom CNC router really aggressively with the Beast CNC router bit, the router bit that I'm releasing from IDC Woodcraft. I want to run this thing as hard as I possibly can until I break the bit. So we're going to see what this thing can really do with this mat here. I'm ready to run the surfacing on this piece of wood using the IDC Woodcraft 1.5 inch ultra smooth. And we're just going to plane that down. What we're going to be watching for is this corner here, but we are in nice and solid. And here we go. We're running at 450 inches per minute. Taking off a 0.07. First pass is going to totally miss. Well, except for that. So there's literally no force being put against the board here, so it's not going to move no matter what. I'm getting dusty over here. I'll have to back up. I'm going to increase my feed rate. So I'm going 500 inches per minute. And I'll have to run a second pass over this because it's missing the back corner. And then we'll set this up with the other bit. The maple board is now surfaced. and I have sawdust all over me. It's one of those things when you're a content creator, I can't use the dust collector. I have to shoot video of the bits in action. And so, of course, I've got my glasses. These are probably not the best ones to be using, but nevertheless, it is time to get into the beast. This is the beast, the hyperspeed roughing end mill for your CNC router. We have the beast mounted in the Phantom CNC router, and we are about to go 800 inches per minute on a profile cut on this piece of maple at 1/2 inch deep, 800 inches per minute. I promise that this time I'm not going to be playing any music for you because I want you to hear how hard this router bit is working, and this is where the rubber's meeting the road, technically, with this mat down here with all the work that the Phantom is going to be applying against the board using this router bit. A lot of force is going to be going against it. Check this out. Damn, that was fast. Let's just pocket this thing out at the same rate. 1/2 inch deep. Removing some wood. Look at that. Just kicking it out. We're going to go at 1,000 inches per minute. Let's see what it does with that. And then we'll do cross grain. And then we'll get deeper. And this padding is holding up very well. Here we go. Pushing that wood right out of the way. We're going to stop it and go cross grain. Our board has not moved a bit against any of this. Maybe I should go an inch. What the hell? One full inch. Well, I am impressed. I was trying to make something fail here, either this vacuum mat, the machine, or this router bit, and I couldn't get any one of them to fail. You and I have both learned a lot here. This video is primarily about a vacuum system, but I was taking advantage of it to test out the beast from IDC Woodcraft. This is one ass-kicking bit, as you now know. But let's recap everything of what you have learned, what I have learned. Before I do, down in the description of this video, everything I talked about, I've got information down below in the description, links, statistics, whatever I can gather, that'll be down in the description. For those of you who can't get to the description, just below this video, you'll see like a sentence and you'll see the word more. Click that word more and that'll open up the description. Okay, so this video is primarily about vacuum systems and the importance of having a good setup with your vacuum system. You know that a vacuum system is a tool to hold your project in place while you're carving it. One of the problems with vacuum systems is they just don't have enough ass, and that's not the problem. Some people think they need to get more pumps. No, the problem is leakage all around the project. And so this padding from All Star CNC, I was very surprised that it was able to hold this hardwood, this piece of maple, under the forces that the Phantom CNC router was applying to it with this CNC router bit. Now, let's just kind of say what we had here. 1,000 inches per minute, 80% step over at a 1-inch depth of cut with the beast from IDC Woodcraft. That's pretty aggressive. That should have moved. Typically, we're going to be screwing this kind of part down to the table so it doesn't move. But now I know how to solve that, and so do you. You got to seal it. You need a good vacuum mat. All Star CNC, from what I understand, is the only company that has this. They have like a patent on it, I don't know. But I will link that down below. You have a vacuum table, I'm definitely going to recommend it. Okay, so now we have the Phantom. I figured that would not be able to handle the forces I wanted to apply to it, which I did apply to it at 1,000 inches per minute, and it did. I want to show you a cut that you did not see in action. Was this pocket here, 1 inch deep, and that's 8 inches by 10 inches. It cleared that pocket out in 1 minute and 30 seconds. That's how aggressive we're cutting with this bit, the beast from IDC Woodcraft. So the Phantom CNC router, I like it. And finally, of course, the beast, you already know about that, again down in the description. So there would be one objection that people have with this, and I have yet to experiment with it when it comes to this vacuum mat. And that is, what if we're doing a cutout? Well, number one, that's the importance of having the spoil board surface before you start putting the mat down. It is a consumable, but from what I understand, not only from the company that sent me the samples, but from other creators or people that have worked with it, that they have gotten quite a bit of use out of these mats before they've had to replace anything. And it's all matter how you set that depth. I'll be experimenting that with in videos in the future. One is going to be an Adirondack chair. That'll actually be the next video I create for the Phantom. So we'll have this down and we will play with it then. Links are down in the description. If this video was helpful, please give me a thumbs up. Teach me about vacuum systems, since I'm still relatively new with them, down in the comments section. Share a little bit more about vacuum systems. I'd love to know. Give me the education, because I am stepping into another level that I haven't worked in a whole lot of with the CNC routers. idcwoodcraft.com